Welcome to RK. Hello dear students, you are welcome to RK Institute. I am Dr. RK Saini and today I am going to discuss Re-NEET examination paper of chemistry. Dear students, I think the paper is quite simple and primarily based on theory and NCERT concept. In fact, I would describe it as a very straightforward and error-free paper. The examiner has designed the paper carefully, keeping the prescribed syllabus in the mind. There are no exceptionally difficult questions. Most of the questions are simple, direct, and based on NCERT textbook. So let's begin our discussion and analyze the paper question by question. Question number first from chemistry. Question 46. This question is taken from Friedel-Crafts acetylation as well as haloform reaction. First, Friedel-Crafts acetylation takes place on the benzene. Therefore, the Friedel-Crafts acetylation, the product is acetophenone. The product is acetophenone. And in second reaction, very important, it is known as haloform reaction. Reaction with sodium hypochlorite. This reagent is also formed by the chlorine and NaOH. Chlorine and NaOH. And it is the reagent of haloform reaction. And we know that methylated ketone undergo haloform reaction. And the reaction in which methyl group change into haloform. Here, chloroform and the remaining part of compound change into corresponding acid. In alkaline medium, we obtained alkanoate ion, particularly benzoate ion, sodium benzoate. Now, check the option. P. If P is solution of sodium salt of carboxylic acid, then Q is primary alcohol. It is incorrect. In which one is P, chloroform, among chloroform and sodium benzoate, one is P and another is Q. Therefore, this option is incorrect. P and Q are aromatic compound, incorrect, because one compound is aromatic and another one is non-aromatic. Second, if P gives carboxylic acid on acidification and Q gives poisonous gas on exposure to air and light, it is correct option. When sodium salt undergo acid hydrolysis, then it change into benzoic acid. The option is correct. And when chloroform react with O2 in presence of sunlight, then very important product, namely phosgene, is produced. And we know that phosgene is a poisonous gas, COCl2, carbonyl chloride or phosgene. This reaction given in your NCERT book. And as option third. Question next taken from complexes 1 is given. Both complexes are octadal. 1 is octadal complexes of Fe. In octadal complexes, 4 valencies are present in the plane and one above to the plane and another one below to the plane. And the chelating ligand is oxalate ion. Oxalate 1, oxalate and oxalate. Due to lack of symmetry, it is chiral or optically active. Therefore, this statement is correct. In another case, chromium. Transform of this complex. It possesses plane of symmetry. It is the transform of this complex. And we know that if transform possesses plane of symmetry, then it is optically inactive and not a chiral. Therefore, the second complex is chiral, is not chiral. And hence option first, statement first is correct and second is incorrect. Statement first correct and second incorrect. Third option is clear. Question number 48. Question 48. This question very simple, taken from GOC, or we can say stability of carbonium ion. The stabilization of secondary benzoyl carbonium ion, in which hyperconjugation as well as resonance is there. The empty p orbital of carbonium ion take part resonance with pi orbital, fulfilled pi orbital as well as sigma electron of CH3 according to no bond resonance or hyperconjugation, sigma pi conjugation as well as resonance is there, and hence filled sigma bond methyl and filled pi orbital both are take part, or we can say in which resonance pi bond as well as hyperconjugation, no bond resonance, both are there. First option. Question next. Potassium alum, ratio of potassium and sulfate ion. First, we write formula of potassium alum. Potassium alum is a double shot. Potassium sulfate and aluminium sulfate. Potassium sulfate and aluminium sulfate, and 24 water molecules are there, in which potassium and sulfate ion. In 1 mole of potassium, 2 potassium ion and 4 sulfate ion. 1 sulfate with potassium and 3 sulfate ion with aluminium sulfate, and hence ratio is 1:2. Question number next, 50. This question taken from biomolecules. Question number 50. Tertiary structure. Correct statement. Tertiary structure of protein has 2 or more polypeptide chain. It is incorrect because tertiary structure contain only 1 polypeptide chain. 2 or more polypeptide chain are present in quaternary structure. Therefore, statement first is incorrect. Next, only protein having quaternary structure are biologically inactive. It is also incorrect. Tertiary and many secondary proteins are also biologically active. For example, when DNA twisting, their polynucleotide chains are connected by hydrogen bonding with nitrogen base, and hence they are secondary structures also. Third, in beta pleated structure, polypeptide chains are held together by intermolecular hydrogen bonding. It is correct statement. Fourth, in alpha helical structure, polypeptide chains are twisted into left-handed. No, in alpha helical, polypeptide chains are right-handed screw. Therefore, statement third, only third is correct. Question next. Number, we are round off 3 figures after decimal. After decimal, when 5, round off the 5. If even number is there, then remain same. If odd number before the 5, then we increase 1, and hence option third is correct. In question 52, find solubility. Solubility of sparingly salt calculate with help of their KSP. In case of question first, the KSP of AgCl, KSP has following relation. KSP equals to S square in case of first. Therefore, their solubility is under root KSP. In case of KSP, is 5 into 10 की power minus 13, or we can say 50 into 10 की power minus 12, and their root is nearly 7 into 10 की power minus 6 in case of AgCl. Then in case of zinc hydroxide, so ZnOH gives 1 mole of zinc and 2 moles of hydroxide ion. Therefore, its KSP equals to 4S cube, and hence the S is KSP divided by 4 root cube is their S. Now putting the value of KSP, their KSP given 1 into 10 की power minus 15 divided by 4 and root cube. The value is 0.25 into 10 की power minus 15 root cube. This value is 6.3, nearly 6.3, and 10 की power minus 6.65. Therefore, the solubility of zinc hydroxide is greater than AgCl. Now, in mercurous chloride, it is also gives mercurous ion. We know that mercurous ion also exists in form of dimer and 2 chloride ion. Therefore, its KSP is 4S cube, and finds S equals to given KSP divided by 4 root cube. Its KSP given 1.3 into 10 की power minus 18 divided by 4, and then find a root cube. And on the solving, 0.325 into 10 की power minus 18 root cube. This value we write 325 into 10 की power minus 21 root cube, and the root cube of 325 is 6.7. 6.7 into 10 की power minus 7. Therefore, its solubility is greater than, its solubility is less, greater नहीं less than solubility of AgCl also. So highest solubility in this question is zinc hydroxide, and lowest solubility of mercurous chloride, and hence option 4th is correct. Question number next. Very simple and straightforward question taken from periodic table. Among the following, correct electron gain enthalpy. Electron gain, we know that electron gain enthalpy of chlorine, or we can say second period element, is less than the corresponding third period element, because the size of second period element are much smaller and high electron density. Therefore, some repulsion takes place between the incoming electron and electron already present in their outermost shell, and hence less amount of energy released after addition of electron. Therefore, the electron gain enthalpy of second period element in P block is less than corresponding third period, or we can say chlorine has highest electron gain enthalpy among all known elements. Third option. Question 54 taken from solution. In case of ideal solution, P and Q, enthalpy mixing 0 or volume change in mixing is 0. The correct statement. No interaction occur between P and Q. It is incorrect. Attraction takes place between the component, but the attraction is similar, or the magnitude of attraction is same or similar than the pure form of component, and such type of solution are known as ideal. Therefore, second statement is correct. Second statement is incorrect and first is correct. First A is correct and R is not correct. Third option. Question next. Amino acid that gives red blood color treating by the sodium fusion extract with sodium nitroprusside. Very good question. And this question taken from qualitative analysis of elemental analysis of organic compound. We know that when sodium extract containing sulfur present in the molecule, then sodium sulfide is formed. And when ionic sulfide treated with sodium nitroprusside, then red or purple color, blood red coloration is taken. And as this question is the test of sulfide ion, and we know that only two amino acids, namely methionine and cysteine contain sulfur in their structure, and as methionine gives this test due to presence of sulfur. Next, question 56. The standard electrode potential half cell given ferric change into ferrous is found with help of this given two electrode potentials. This question taken from electrochemistry. We know that electrode potential is an intensive property, and intensive property is neither be added nor added, subtract, and hence to calculate electrode potential we use free energy change. Our aim is find Fe plus 3 change into Fe plus 2. It is our aim, and the given question and given data, first Fe plus 3 plus 3 electron change into Fe, and its electrode potential given minus 0.04 volt. Equation 1. And in second equation, we write in reverse form Fe gives Fe plus 2. Fe gives Fe plus 2 plus 2 electron, and its potential write with positive sign because equation become reverse. These electrode potential given, and it is aim. When added equation first and second added, then we find equation number third. Therefore, if free energy change of equation first is delta G1 and second is delta G2, and free energy of equation third aim is delta G3. Putting the value of, we know that delta G equals to minus NFE. In case of first, N equals to number of electron 3, F and potential given minus 0.104. In case of second, minus N is 2, F and potential given 0.44. And in third, electron is 1, and we find electrode potential of unknown electrode. On solving this question, plus 0.12 F minus 0.88 F equals to minus F E third electrode. That on solving the question, we find minus 0.76 F equals to minus F and E third, and hence the final answer is plus 0.76 volt, plus 0.76 volt with help of free energy. Question next, 57. This question taken from mole concept, particularly redox reaction. By the use of law of equivalence, we know that gram equivalent of oxalic acid equals to gram equivalent of KMnO4. We know that gram equivalent equals to N into V, divided by 1000. Or normality, we know that normality is equals to molarity into N factor. Molarity into N factor into V. Similarly, molarity into N factor into V. In this question, molarity of oxalic acid given 0.25. Its X factor is 2 and the volume is 10 ml. And the molarity, we find molarity of KMnO4. Its in acidic medium is X factor is 5 and volume is 10 ml. And hence the molarity of KMnO4 is 0.1 m. Option first. In case of KMnO4 in acidic medium, it change into Mn2 plus, and hence its N factor is 5. The oxidation state of Mn in this compound is plus 7, and in product oxidation state of Mn is plus 2. Atom balance, and we added 5 electron from reactant side. Therefore, it gain 1 mole of KMnO4 gain 5 moles of electron. Therefore, its N factor is 5. In case of oxalic acid, N factor is 2 because during that redox reaction, oxalic acid change into carbon dioxide. And the oxidation state of carbon is plus 3, and 1 mole of oxalic acid contains 2 moles of carbon. And in CO2, the oxidation state of carbon is plus 4. First, balance the atom and then balance the charge by the using of electron. It means 1 mole of oxalic acid lose 2 moles of electron. Therefore, its N factor is 2. Question number 58. Question 58 is very simple and straightforward, taken from spectrochemical series of your NCERT book, Coordination Chemistry. CO is strong ligand, then ammonia is strong ligand, then water, and chloride is weakest ligand in given question. Simple question and given your NCERT book. Question number 59. Question 59. It is very important question taken from thermodynamics. And we find entropy, change of system and surrounding. We know that the entropy of ideal gas means system is NCV ln T2 upon T1 plus NR ln V2 upon V1 for system. Isothermal constant, temperature is constant, therefore this value is 0, and then putting the value N 2 moles to N2 are taking ln, convert ln into log, therefore we use 2.303 log. Final volume is 100 liter, initial volume is 10, and hence log 10 equals to 1. Therefore, our answer is 4.606 R in case of system. In case of surrounding, it is isothermal process. Therefore, the no internal energy change in case of ideal gas. Free expansion means no work involved, and according to first law of thermodynamics, no heat exchange. First, isothermal ideal gas, therefore no internal energy change. The process is free expansion, therefore no work involved, and according to first law of thermodynamics, no heat exchange. Therefore, no heat exchange, then hence the entropy of surrounding is zero, because Q upon T, Q 0, then T, and hence answer is 0. Therefore, system 4.0 is answer 4. Question number next, 60. Very important question. Or I think these are the questions are conceptual. We write rate law equation for zero order reaction. The stoichiometric coefficient of A. According to rate law equation, we write rate change in concentration of A upon 2 dt is directly proportional to concentration of A की power 0, because it is zero order reaction by experiment. And the stoichiometric coefficient of A is 2, divided by 2. Proportionality change by the constant, and then integrate the equation. And on integration, we find kT, 2 kT. We find 2 kT equals to A naught minus AT. Then find T. A naught, initial concentration, minus concentration after time T upon 2 into K. Initial concentration, in this question, initial concentration given 2m. After 75% completion, the remaining concentration is 0.5 of 2m, and the K given is K of the reaction is given 1 mole per liter per minute. K is given 1, and hence 1.7, 1.5. And hence 1.5 divided by 2, and our answer is 0.75 minutes. 0.75 minutes. Second option. Question number 61. Question 61 taken from D and F block. Very easy statement first. Assertion दे रखा है. Generally 3D element in general 3D transition element have high melting point. Correct, right? Because they are melting point. The reason, involvement of 3D electron in addition to 4s. Yes, because ns as well as n-1d electron take part in bonding, because their energy difference is very less, or we can say due to comparable energy. Unpaired electron of n-1d are also take part in bonding, and hence they are very hard, high melting point, boiling point, and have high atomization enthalpy generally. Therefore, reason correct and assertion is correct. Option first. Question 62. Very important question taken from electrochemistry. According to Debye-Ekal-Onsager equation, the molar conductivity equals to limiting molar conductivity minus B slope on concentration loop. It is known as Debye-Ekal-Onsager equation. In this question, given molar conductivity 145, slope given and concentration given, and hence we find limiting molar conductivity of the salt. Slope given minus 90, and concentration given 10 की power minus 2. Therefore, limiting molar conductance, this value is 9. And as limiting molar conductance is 154 plus 9 of the salt is 154. Now we know that limiting molar conductance of salt is sum of the limiting molar conductance of cation X positive and limiting molar conductance of anion. Value of limiting molar conductance of cation is given. Cation, the complete limiting molar conductance of salt is 154, and limiting molar conductance of cation is given It is value 74. Therefore, we find limiting molar conductance of anion Y. Subtract the value and our answer is 80. Question first. Very simple question. And this Debye-Huckel-Onsager equation is related to the molar conductance, limiting molar conductance, and concentration and effect of dilution. Kohlraau's law. Effect of dilution on conductance. Taken from Kohlraau's law, or this equation is known as Debye-Huckel-Onsager equation. Question next. Very simple. Amount of carbon dioxide evolved upon complete 116 gram N-butane, complete combustion of 116 gram of N-butane, C4H10. On their complete combustion, it gives 4 moles of CO2. 1 mole gives 4 mole. Their molar mass 58. Therefore, their mole 116 divided by 58, and hence their mole is 2. And hence we obtained 8 moles of CO2. And we know that 1 mole of CO2 has molar mass is 44. Therefore, our answer is 352 gram. 352 gram. Answer 352 gram. By mistake, 352. Answer 352 gram. Maybe second or third. Anyone हो सकता है ये लिख रहा हो. 352 gram. Option second. Question next. Very important question taken from chemical kinetics as well as combination of thermodynamics. In this question, Re-NEET equation graph given ln k and 1 upon t. We know that Re-NEET equation k equals to a e raised power minus ea upon rt. We write in term of ln k equals to ln a minus ea upon rt ln e power e. This is very important for NEET student. In case of mathematics student are understood and they are very easily known, but in case of JEE student, NEET students, ln e power e equals to 1, and hence the complete equation is ln k equals to ln a minus ea upon rt. In given equation ln k, intercept represent ln k, it is 6, and k rate constant a e की power 2. It means ln e raised power 2 equals to 6 minus ea upon rt. We know that ln e की power 2 means 2, and hence 2 equals to 6 minus ea upon rt, or we find ea upon rt equals to 4. ea upon rt equals to 4, and temperature ea upon r into 4 equals to T. ea given in kilojoule, R and divide by 4. Therefore, we find temperature of this reaction. Question next. Question next, 65, taken from D and F log, particularly formation of the KMnO4 by pyrolusite method. When NaCl concentrate H2SO4 and MnO2 resultant oxidation. No, when MnO2 react with NaCl in presence of concentrated H2SO4, then Mn plus 4 reduced in acidic medium, Mn plus 4 reduced into plus 2, and hence it reduced into plus 2 and evolved HCl gas, that is brown fume, slightly white fumes, HCl in case first. Therefore, statement first is incorrect because no oxidation but reduction of amine. In case second, when NaI concentrated the same reaction, but we taken NaI. It is salt analysis. Question taken from salt analysis. Test of iodine. When test of iodine is takes place, then HI. HI is further reduced. Mn2 and the product HI is further oxidized by H2SO4 concentrate H2SO4 as well as MnO2, and it gives iodine and SO2. Therefore, above the heating of concentrate, Mn is reduction of Mn. It is correct option. Mn plus 4 reduced into plus 2 in acidic medium. Therefore, statement first is incorrect and second one is correct. Question next. Question next, 66. Taken from coordination compound. Highest spin magnetic moment. Highest spin magnetic moment depends upon the number of unpaired electron, and the simple formula is root n plus 2, where n is number of unpaired electron. In case of Mn, oxidation state of Mn is plus 3, and in plus 3, 4 electron present in D, and in octahedral complex, DD transition takes place and strong field ligand. Therefore, 4 electrons are occupied in T2G orbital. Therefore, n equals to 2. In case of Fe, Fe plus 3 also, and in case of 3D 5 and strong field ligand is there. Therefore, only one unpaired electron is there. Only one, n equals to 1. In case of CO, this is strong field ligand and has no unpaired electron. Cobalt plus 3 and 3D 6 electron, and as all electrons are paired in T2G, therefore no unpaired electron. In option 4, titanium, oxidation state of titanium is plus 3, therefore only one electron present in D orbital. Titanium plus 3, only one unpaired electron is there, and hence option first is correct. Number of unpaired electron. Spin magnetic moment depends upon the number of unpaired electron. Highest number of unpaired electron present in complex first, and these are the 2 electrons. Question next. 76. Taken from electronic configuration of lanthanoids. Four element electronic configuration. The atomic number of cerium, niobium. Cerium, atomic number 58. We know that the electronic configuration of cerium is xenon, 4f1, 5d1, and 6s2. First element. Now we write it. This is the exceptional electronic configuration because energy, according to n plus L rule, the energy of 5d orbital is greater than 4f. Therefore, no electron present in 5D, but exceptionally electron present in 5D. In case of neodymium, 2 more electron, atomic number 60, and as electronic configuration is xenon, 4F, 4, 5D, 0. It is correct electronic configuration, no exception. In case of terbium, electronic number 65 means 5 more electron also. Xenon, 4f9, 5d0, and 6s2. In case of holmium, 2 more electron than terbium, 67, and as its electronic configuration is xenon, 4f11, 5d0, 6s2. So, dear students, I can say you learn electronic configuration of first and last element of lanthanides as well as actinoids, and then electronic configuration are so smooth. And as now we make trivalent cation. In case of trivalent cation, cerium, 1 electron present in d orbital, 1 electron present in f orbital, 3 electron. Therefore, cerium plus 3 contain 1 f electron. In case of neodymium, triminium, 2 electrons 6s and 1 electron from 4f, and hence it contains 3 electron in f, in which The examiner required 4 unpaired electron. In neodymium plus 3, only 3 unpaired electron. In case of terbium, their trivalent cation contain 8 electron in F. We know that F subcell contain 7 orbitals. 7 orbitals. And electrons are occupied according to Hund's rule. 1, 2, 3, 4, 5, 6, 7, and 8. 7 orbitals. And this is the 8. And as it contains 6 unpaired electrons are there, it is also incorrect. In case of holmium plus 3, 2 electrons from S and 1 electron from F. Therefore, 10 electron. And arrangement of 10 electron according to Hund's rule. 7 orbitals are there in F. 1, 1, 1, 1, 5, 6, 7. And then pairing takes place. And as holmium plus trivalent cation contain 4 unpaired electron. And as our answer is holmium plus 3. Question next. Also taken from coordination compound. Simple IUPAC name. Tetraamine aqua chlorido. 4 amine aqua and chlorido are ligand. Only 4th option, and oxidation state is 3rd, 1 chlorine inside the coordination sphere and 2 chlorine outside the coordination sphere. And 4. Question 69. Very important or simple question. And these such type questions are very conceptual question. 1 mole of ideal gas take part in following reaction. First process, step first. Step first is isothermal. First step is isothermal because temperature T1 and temperature T1. And in first step, isothermal. Second and fourth are given adiabatic process. Second and fourth are adiabatic. Third step is also isothermal because the temperature at point 3 and at point 4 are also equal. And the first and third isothermal, second and fourth adiabatic given in question. Then we check the option. Option first, W1 plus W2. Option first, W1 plus W2 equals to. In case of W1, step first. W1 equals to minus nRT ln V2 upon V1 plus next in second minus nRT. In step first, temperature is T1 and in second W1 plus W, I think it is not W3, it is W1. I think this is incorrect typing mistake, or it is W3. And as W3 is also nRT2 plus ln V4 upon V3. N equals to 1 mole. N equals to 1 mole. Temperature T1. Therefore, minus RT1 ln V2 upon V1 minus RT2 ln V4 upon V3. And R equals to 2. Therefore, first option is correct. Minus 2T1 plus, minus 2T1 ln V2 upon V1 minus 2T2 ln V4 upon V3. Option first is correct. W1 plus W3 equals to this. Answer first is correct. Second one is incorrect because question W2 and W4 both are adiabatic. Therefore, their work equals to change in internal energy because in adiabatic process Q is 0. And as W1 plus W4 equals to Q2 internal energy 2 and internal energy 4 plus sign. But given is minus sign. Therefore, it is incorrect. In case of W1 plus W3, no, W1 or W3 this, and net work is not 0 because work is not a state function. It depends upon the cycle, and net work of this process is the area under the given curve or given graph. It net work this, not 0. Question number 69. Then we can check question number 70. Question 70. Assertion. First ionization enthalpy of oxygen is lower than nitrogen and fluorine. It is correct statement because nitrogen has half-filled electronic configuration, but oxygen has normal electronic configuration. The first ionization enthalpy of nitrogen is greater than oxygen, and it is also less than fluorine because fluorine is smaller in size, high ENC. In statement second, the loss of one electron from oxygen led to stable half-filled electronic configuration. Therefore, statement first and reason both are correct. First answer. Because after removal of one electron, oxygen become half-filled, and hence its ionization and second ionization will be greater than fluorine also. Question next. Mixing of two liquids. First, ideal solution form obey Raoult's law throughout the composition range. Correct answer. Mixing of chloroform acetone, so negative deviation of Raoult's law. Bilkul, it is also correct because hydrogen bonding takes place. These examples are directly given in your NCERT book. Dear students, I can say you always learn and read your NCERT book because such type of examples are directly given your NCERT book. Acetone and chloroform. So negative deviation because make hydrogen bond. This example is also given the mixture of aniline and phenol. So negative deviation from Raoult's law. So positive deviation. It is incorrect. This example is also given in your NCERT book, and hence option A and B are correct. A and B are correct in case of 71. Question next. Question 71. Question 72. Very easy and simple reaction. The reaction of Grignard reagent given with primary amine. We note that primary amine contain active hydrogen, and active hydrogen means they furnish H plus ion. And in Grignard reagent, magnesium carry positive charge and carbon negative charge, and hence anion react with H, and hence the product is cyclohexane only. Fourth option, nothing. Question next. This chemical bonding. Boron has maximum maximum covalency of 4. It is correct option because boron is second period element and contain only 2s and 2p, means 4 orbitals. Therefore, its maximum covalency is 4. For example, BF4 negative is such type, BH4 negative such type, in which valency or covalency of boron is 4. Correct option. Baridium has 3 valence orbital, 3 9 4. It is incorrect. Magnesium has maximum covalency 4 9 6 because it is third period element. Aluminum has 5 valence orbital. It is incorrect. Contain 9 valence orbital because aluminum is also third period element and has 3s, 3p and 3d. Valence orbital 1, 3 and 5, 9 orbitals. Therefore, option first is correct. Very simple and basic concept from chemical bonding, or we can say inorganic chemistry. Question next, 74. Good question. And is the mixed question of chemical equilibrium as well as thermodynamics. Check the question. Protein denaturation N into P at concentration both. At equilibrium, the concentration of N and R equal at equilibrium. It means its equilibrium constant, the concentration of D upon concentration of N. Both are equal. Therefore, the equilibrium constant is 1. Now, we use relation between equilibrium constant, enthalpy and entropy change. And we know that ln equilibrium constant equals to minus enthalpy change RT plus entropy change upon R. Equilibrium constant 1, therefore their ln is 0, and hence this value is 0. Therefore delta H naught upon RT equals to delta S naught upon R. R is also cancelled. Therefore delta H divided by T, then we find delta S. Delta H in this question is given 666. Very simple, and these are the based upon fact. or formula based or simple elementary question, and the combined, and this question is prepared by the chemical equilibrium as well as thermodynamics, by the use of thermodynamics. Delta H, enthalpy change given 666, and the temperature given 60 degree centigrade. 60 degree centigrade convert into Kelvin 333, and hence our answer is 2 kilojoule, first option. Question next 75, very simple and based upon hybridization in chemical bonding, simple geometry and hybridized shape. PCl5 sp3d PCl5 sp3d and as trigonal bipyramidal. Simple molecular shape. PCl5 trigonal bipyramidal in Br5 sp3d. Therefore, the hybridization is says octahedral and the geometry is square pyramidal due to presence of one lone pair. Therefore, the molecular shape. Actual term is used by the examiner is molecular shape. I think actual term can be used molecular shape. In case of Br4, Bf4 negative tetrahedral and NiCl4 is square planar. It is the square planar complex taken from coordination compound also. Question next 76, very important question. We know that geometry or stereochemistry of addition reactions, you check CAR and TAM, cis alkene anti-addition. In case of anti-addition, the product is car and trans gives meso. In case of syn addition, CSM and TSR. Now we check in statement first. Trans 2-butene react with bromine. Trans 2-butene react with bromine. It is anti-addition. Trans anti-addition. The product should be meso. Check this compound is meso or not. Now we make 2D Fisher projection formula of Newman structure, and Newman structure always gives Fisher projection formula by their eclipsed form, and in eclipsed form group or atoms remains constant of one carbon and other rotate simultaneously, by which they change into eclipse H, Me and Br, and now make their Fisher projection. In first carbon Br top, in left hand side H, in right hand side Me. H opposite or eclipsed form of Br, eclipsed form of H, and Me eclipsed form of Me, and we find actual Fisher projection formula. Their vertical line represent principal chain of the compound and then simultaneously rotate of these groups. Therefore, Me, Br and H in top carbon similarly simultaneously rotate, and as Me, H and Br. It is not a meso. Therefore, statement first is incorrect. Next, check second. Statement second. Cis-2-butene on treatment with KMnO4, alkaline KMnO4 means it is Beer's reagent. And alkaline KMnO4 gives syn addition, and cis alkene gives syn addition, and hence product should be meso. Check. First, we make eclipsed form of Newman projection. Groups of one atom remains constant and another groups are simultaneously rotated, by which it change into eclipsed form OH, H and Me at first carbon, and in bottom H in eclipsed form of OH, eclipsed form of Me, and Me in eclipsed form of H. It is the eclipsed form. And now we write their Fisher projection formula. In carbon top OH first, and left hand side in H and right hand side is Me. In second, OH and H are eclipsed form. Me and OH are aqueous form, and H and Me are aqueous form, and we write actual physal projection formula by which principal chain become vertical line, and hence carbon first simultaneously rotate Me, OH and H. Similarly, second carbon is also rotate Me. This one is Me, H and OH, and hence it is mesoform. Therefore, the statement second is correct. Statement second, cis-2-butene treatment with alkaline KMnO4, it is Bayer's reagent, and hence in addition takes place. Statement first is incorrect and second is correct. One third answer. Question next. Very important question taken from hydrocarbons. First, reduction of alkyne with Lindlar catalyst. In case of first, reduction with Lindlar catalyst means syn addition takes place, and hence the product is cis-alkene, HH, and this one is phenyl, and this one is Me. In case of sodium and liquid ammonia, trans addition takes place, it is product K, and in trans reduction, it gives transalkene. Transalkene means L is double bond and transalkene, phenyl and Me. Therefore, option first, K and L are geometrical isomers, correct answer. Now, we add HBr in presence of peroxide. When peroxide HBr is then formation of the free radical, and hence, after addition of bromide free radical, it change into phenyl, CH odd electron, CHBr and Me. And after addition of H, the final product is PH, CH2, CHBr, Me. After addition of HBr in presence of peroxide, this is the final product, or it is N. In case of simple addition of HBr according to Markovnikov, therefore first addition of H plus ion and hence formation of following carbonium ion due to more stable resonance. Therefore, this carbonium ion is formed after addition of H, and after addition of Br, the final product is PH, CHBr, CH2, Me. And we consider compound N and M. These are the structural isomers. Therefore, no stereoisomers. And hence only option first is correct. M are geometrical, no. Question number 78. Also taken from coordination compound. Simple. Which of the simple question and taken directly from your NCERT book. The which compound show facial and meridional isomers? We know that A3B3 type of compound show facial and meridional, because when three similar donor site, donor ligand occupy triangular facial, then it is known as facial. Above and below, and where they are meridional are known as meridional, and hence only first option is correct. 3 pyridine and 3 Cl chloride ligands, and hence it's so facial and meridional. Simple question and directly based upon your NCERT book. You can be check your book. Question next. 79. Simple. The reaction which give aniline as a major product. The reduction of cyanide by LiLH4. The product reduction of cyanide by LiLH4. The product of cyanide give primary amine but not aniline. Cyanide group change into CH2NH2. It is not aniline. In case of amide, reaction with KOH and Br2, very important. This reaction given your NCERT. This reaction is also given your NCERT book. This reaction is also given your NCERT book. In case of amide, aliphatic or aromatic, when Br2 and KOH, the reaction is known as Huffman degradation, and CO group is eliminate. Finally, CO group is eliminated and the product is primary amine or aniline. First option. In case of nitro, reaction with NaBH4. NaBH4 not react with nitro because it is selective reducing agent, and nitro benzene is more stable compound, not react. Then NaBH4 generally used for reduction for carbonyl compound, aldehyde ketone as well as acid halide. Generally, not react with nitrobenzene because stable. In case of amide, this case of amide, first HCl, then hydrolysis. In case of acidic hydrolysis, all acid derivatives, all acid derivatives are changed into acid. Therefore, this compound gives aniline also, where H and OH, acetic acid and OH, and on heating. And as option B and D gives aniline also. Question number next. Question 81. Very simple. Your NCRT book, directly given your NCRT book in biomolecules, vitamin A, major source of vitamin A is carrot. All student are, you are the student of NEET, and as also known by the biology, and as vitamin A, major source is carrot. Vitamin B12, major source is meat. Vitamin E and B, and directly given your NCRT book, vitamin K given by leaf, vegetable leaves. Vitamin E, sunflower is, that is right. Question next, correct? Decreasing order of the oxidation state of the underlying atom. The oxidation state of phosphorus in this is +5, and the oxidation state of sulfur is +6. Incorrect. The oxidation of lead in there is +4. Nitrogen is +5. Incorrect. Oxidation state of nitrogen in 5. Aluminium is +3 and sulfur is -2. It is correct option. In P4O6, oxidation state +3 and Cl is +7. No decreasing order. Therefore, second is correct. Question next. Very good question. I think this question is very important and very good question select by the examiner for NEET examination. Very good question. And this question taken from carbonyl compound, particularly aldehyde. Aldol condensation. We know that aldol condensation may be self or cross. But if no alpha hydrogen in one compound, then it is cross aldol condensation takes place. In case of first, this active H gives into the active H and nucleophile, and this nucleophile attack on this ring. Check the product of question first. This ketone make nucleophile in alkaline medium, and the attacking species is benzaldehyde, and their aldol product, this carbon attack this carbon, and their aldol product is it is their aldol product. On their heating, also given heating. On their heating, they eliminate water and make alpha beta unsaturated carbonyl compound, OH and H, remove from the alpha beta, and the final product is double bond takes place between this carbon and this carbon, and contain phenyl. This compound, and we know that this compound shows geometrical isomerism, and hence structure 2 and 4 are possible in case of cross aldol condensation, or one molecule contain alpha H and another lack of alpha H, and as this ketone gives nucleophile and aldehyde act as a substrate. Therefore, product second and fourth are possible by the geometrical isomerism. Now, same aldol condensation, yes, self aldol condensation takes place. The product is in self aldol, the product are possible. Following product possible in self aldol condensation. Two molecule same of ketone are taken. One generate nucleophile and another acts as a substrate. This and second molecule. This molecule generate nucleophile after removal of H plus ion, and this carbon attack at this carbon, and hence aldol product is following type. This carbon change into OH and attach that carbon. It is aldol product. On their heating, elimination of water and product is alpha beta unsaturated. OH from this and H from this. And hence, the final product of self aldol is double bond where two methyl groups are also present. Two methyl groups are also present at this carbon. And as this product is alpha beta unsaturated carbonyl compound. This product is third of in case of third answer. And as product first is impossible because after aldol condensation the final product is alpha beta unsaturated carbonyl compound. It is known alpha beta. Then functional group present at the carbon, it is known alpha, and this is known as beta. Alpha beta, alpha and beta. And as when functional group present at the carbon is known as alpha. Therefore, it is not alpha beta. First option is incorrect. Question number next, 82, 83. Very simple. Taking from general nomenclature, which one of the following compound having conjugated dienes? Conjugated means in which alternate double, single, double bond are there. And as first option is correct. Hepta 1,3-diene, alternate double, single. Question number next. Question next. Oxidation of para-nitrotoluene with acidic KMnO4. This is para-nitrotoluene. Oxidation with acidic KMnO4 in drastic condition. The product is para-nitrobenzoic acid. CH3 change into COH. Para-nitrobenzoic acid. Give stronger acid than benzoic acid is correct statement. A reduction of para-nitrotoluene with SN, HCl and followed by neutralization. This reagent nitro group reduced into NH2 group. And hence the product is CH3NH2. Neutralization for HCl, otherwise it change into salt. After neutralization, acid is removed and the product is this. This product is more basic than aniline. It is also correct because plus I as well as hyperconjugation effect of methyl group at para position. Therefore, electron density increase at nitrogen and more basic than aniline. Both statements are correct. Statement first and second both are correct. The next question. Question 85. This question directly given your NCERT book for chemical properties or properties of KMnO4. When KMnO4 and K2Cr2 both are heated, then they evolve oxygen gas and change into KMnO4 change into K2MnO4. K2MnO4 is green colored compound. When KMnO4 heated at this temperature, then it change into K2MnO4. It is green colored compound. MnO2 means again pyrolusite plus oxygen. And as first answer is correct. Question next. Very important question. Directly given your NCERT book. This is known as method of preparation of benzaldehyde. The reaction is known as Attard reaction. Chromyl chloride, carbon dioxide and hydrolysis. Then the final product is benzaldehyde. Then on treating the product P with sodium bicarbonate solution, Brix effervescence are evolved. It is incorrect because it is not acid which evolves CO2 with sodium bicarbonate. Incorrect. Question next. When P prepare treatment of the benzene with anhydrous, it is incorrect. When benzene undergo Friedel-Crafts reaction, acetylation, then product is acetophenone, non-benzene, not benzaldehyde. It is also incorrect. On treatment with bromine water, P gives white PPT. It is also incorrect because deactivating group. And with Br2, it gives meta bromobenzaldehyde, not precipitate. When 3 bromine present at the benzene ring, like as in aniline or phenol, then white precipitate takes place. It is also incorrect. Compound P can be obtained by the hydrogenation of benzoyl chloride with PDBS for very good reaction, and this reaction is also given your NCERT book. And this reaction is known as Rosenmund reduction. When benzoyl chloride reduced in presence of PD and BSO4, the reaction is known as Rosenmund reduction, and hence the product is benzaldehyde, where barium sulfate acts as a catalytic poison. And hence the option 4 is correct. Question number next. 86. Question 87. 1,3 electrolyte. Many questions comes from coordination compound. 1,3 electrolysis. 1,3 electrolyte in aqueous solution. Means this is the 1:1. This compound carry 1 cation and 1 anion. This compound carry bivalent cation and 2 anion, 2 chloride ion. This compound carry trivalent cation and 3 chloride ion, and hence it is known as 1:3 electrolyte. Question next, 88. Some graphs are given from wave function and distance from the nucleus, and we identify graph in which 2 radial node are there. Radial node represent 2 radial node. Question, which graph in which represent 2 radial node? Represent 2 radial node. Radial node is a part of wave at which it change into the side, where no radial node. This point is represent radial node. This point represent radial node, 1 radial node. In this graph, 2 radial node. When wave change their sign, then it is known as radial node. 1 radial node and 2nd radial node. And as this is correct, only 1 radial node. Graph 1, 2 and 3 are related to s orbital, and this graph related to maybe p, d and f also. And as only C is correct. Question 89. Which of the following according to polarity? Polarity of the molecule depends upon polar group. Depends upon polar group, as well as means dipole moment, as well as group present at the compound make hydrogen bonding, etc. Polarity, hydrogen bond. And as in case of first ether, only polar group is there. No H bond formation tendency with other compound, means slightly polar. In case of alcohol, second option, in case of alcohol, hydrogen bonding, polar protic solvent is there. In acid, polar group. In case of acid, polar group, highly polar carbonyl group, as well as hydrogen bonding tendency. Therefore, highly polarity of D, then alcohol, then ketone due to CO, and less polar of ether. And then highest polar acid, then alcohol, then ketone and ether. Option 4. Next question. Next question. Taken from chemical bonding, particularly MOT. Identify HOMO. Highest occupied molecular orbital. Highest occupied molecular orbitals means the molecular orbital which contain electron have highest energy in case of Ne2. Ne2 means total 20 electrons are there. When we fill the molecular orbital according to their energy level, for example, sigma 1s, sigma star 1s2 and so on, and the final highest orbital is sigma star 2pz2. Therefore, the highest occupied orbital is sigma star 2p. Answer 4. This is the your paper and answer key of code number 50. Okay. Thank you.